Today's lesson is Unit 1, Lesson 6 on function equations, Part 2. So as a reminder, a function is like a relation in that you have specific domain values matched with exactly one range value. And you can think of a function as kind of being like a function machine, where the numbers that you put in to your function are the domain values. The equation is the rule of the function, so the process that you're doing, and then the output is what you get out, the range values. So domain, the x values is what you put in, the equation is the rule of the function, and the y values are the range that you get out. So using the function machine, if you have a given set of domain values, so for example, -1, 2, 3, and 6, you can plug these values into your equation to get your range values as outputs. So for this equation, if I were to plug in -1 for x, you would have 2 times a -1 and then plus 1. So -2 plus 1, and that would come out to equal -1. So our first range value is a -1. If I try that again, but instead this time I plug in 2, 2 times 2 is 4, so we would have 4 plus 1, and we'd get out 5. So our next value is 5. If I were to do it with a 3, plugging in 3, 2 times 3 is 6, 6 plus 1 is giving our next value to be 7, and our last one, 2 times 6, so 2 times x, 2 times 6 is 12, 12 plus 1, our last range value is 13. So you're using that equation to get your range values. In this example, notice we have two variables. If I were to plug in -2 for each of those x values, so 5 plus 3 times the -2 minus 5 times the -2 squared. So remember your order of operations. We have 5 plus a -6 minus 5, and then -2 squared is 4. Continuing to simplify, 5 plus a -6 minus 5 times 4, think of that as -5 times 4, so minus 20. And then now adding from left to right, 5 plus a -6 minus 20 gives us an answer of -21. And then you would continue for the other values, plugging in -1, 0, 1, and 2 into your function to get the rest of your range values. Another way to look at functions, still finding the range, in these examples, they're telling you to evaluate the function of g when n, when n equals -6. So this number in parentheses is telling you what to replace that variable with. So if I were to try this, 5 times a -6 minus 18, -30 minus 18, our first number would be a -48. Trying it with -3, so 5 times a -3 minus 18, so -15 minus 18 will give us a -33. And next one, plugging in 0, 5 times 0 minus 18. This ends up being 0, so we get -18. Last one, 5 times 5 gets us to 25 minus 18 for an answer of 7. So here are different range values, and you could list them all in that set notation. And finally, one last thing I want to make sure that you understand is the difference between finding the function f of 0 and when the function says f of x equals 0. So the main difference between the two, if it's f of 0, So this one here, f of 0, it means that you're replacing 0 in wherever you see x. So just like this example here where this number is what you plug in, when there is a 0 in here, that's the number you plug in for the variable. When it's f of x equals 0, this means you're trying to find the value of x that will make the entire solution to the function 0. So it makes the equation equal to 0. So in this example, you're trying to find x, and you're trying to figure out what a value of x makes that equation equal 0. So here's an example of it worked out. If this is our function equation, and they want us to find for f of 0, that meant to plug in 0 for x. So 2 times 0 is 0, plus 5. We get f of 0 equals 5. In the other example, f of x equals 0, that means we're taking that equation, that 2x plus 5, and figuring out when it equals 0. So here's our function equation. If we have 2x plus 5, 2x plus 5 equals 0, then you're going to use inverse operations to solve. So we'd subtract 5 on each side so that our 2x term is by itself. And that's how we end up with 2x equals negative 5. And then the last step, to get x by itself, you divide each side by 2. So x could equal negative 5/2, or as a decimal, negative 2.5. So make sure you recognize that there is a difference between f of 0 and f of x equaling 0.